In this video, I'm going to be going over the three main logarithmic properties. So the three properties are the product rule, the quotient rule, and the power rule. And the purpose of these rules is to kind of rearrange a logarithmic expression to get it into a form that we want. And this is especially useful when we're trying to solve log equations, which we'll see later. All right, so the first rule is the product rule. So if I have an argument that is a product, so an argument that two things are getting multiplied together, I can split that expression up into two log terms with the same base, but where I'm adding those terms together. So if I want to expand log base b of 8k, that's just going to be log base b of 8 plus log base b of k. And one way to remember this is logs correspond closely with exponents. So if I had x to the 2z, let's say, that's going to be the same thing as x to the 2. Actually, hang on. Just making it up on the fly here. Let me make sure I have this correct. So if I have x to the 3rd times x to the 5th, what we do is we add those together. Okay, so when I'm multiplying those bases that are the same together, I add those exponents. Okay, so for the quotient rule, if I have a quotient inside the argument, I'm just going to subtract those. So log base 3 of x divided by 3y, that's going to be log base 3 of x minus log base 3 of 3y. So that is one expansion, but notice now I have a product in here and I can do what we did up here. So log base 3 of x minus, now be careful, you want to put this in parentheses because that minus is telling us we're going to subtract no matter what comes after it. So this is log base 3 of 3 plus log base 3 of y. So if we don't have that minus sign in front, by putting that minus sign in front, it's going to get distributed through. And if we didn't do that, we would do this incorrectly. So this is, we could leave it as it is, or we could say log base 3 of x minus log base 3 of 3 minus log base 3 of y. All right, and we can remember this rule because when I'm dividing terms that have the same base, I subtract those exponents. So x 5 minus 3 is equal to x squared, like this. Okay, and then lastly, we have a product rule. So if I have a power rule, I should say. If I have a power or an exponent inside the argument, what can happen is that exponent can become the coefficient for the expression. So let's expand ln of x cubed divided by y. The first thing I'm going to do is I'm going to rewrite this using the quotient rule. Okay, and then notice I have that power inside the argument of the first term. So this will become 3 ln of x minus ln of y. Okay, and the one way to remember this rule is if I have x to the 3rd all raised to the 5th, I'm going to multiply 3 times 5. So this becomes x to the 15th. So a couple other examples of expanding these exponents using the rules. So ln of x to the 4th times y all divided by 7. Usually we want to take care of the quotient portion first. So ln x to the 4th times y minus ln of 7. That's using the quotient rule. This first term is a product, ln of x to the 4th plus ln of y minus ln of 7. And then in that first term, the 4 can go down as a coefficient. So 4 ln of x plus ln of y minus ln of 7. And we can always check this by going the other direction, putting it back together and seeing if we get what we started with. This next one, again, I'm going to expand using the quotient rule first. Log base 6 of x plus 1 squared minus L log base 6 of yz. Now, this squared is still inside this argument here, so the 2 can come in front. 2 log base 6 of x plus 1 minus, and I have this product here, so I'm going to write it in parentheses, log base 6 of y plus log base 6 of z. And like the one we saw above, we can distribute this. We don't have to, but I will. So 2 log base 6 of x plus 1 minus log base 6 of y minus log base 6 of z. Okay. And then the next two examples are going the other direction. So we want to condense these two expressions into a single logarithm. Just like we saw before, we can apply these rules when the bases are all the same. So for this first example, these are all base 10, so I can combine these. And I'm just going to do 2 at a time here. So log base 10 of 3, log base 10 of 4. If I'm adding those, that means I'm going to multiply the arguments together. So this can become log base 10 of 3 times 4, so log base 10 of 12. And then I'm going to factor out that negative plus log of 7. Okay, so now I can put these two together. This will be log of 12, base 10 of 12 minus log base 10 of 5 and plus log base 10 of 7. That's going to be log of 35 here. So I have two terms, same base, I'm subtracting, so I can write those arguments as a quotient inside the argument. So log base 10 of 12 over 35. All right, and then this next one, I'm going to work what's inside the parentheses first. This quotient, this power is going to become an exponent. So 4 times ln x cubed. Again, I'm going to factor out the minus. This will be ln of x plus 5 plus ln of y. And close that outside parenthesis. So inside these square brackets, I'm adding, so I'm going to multiply x plus 5 times y here. So we're bringing everything down, ln x cubed minus, this will be ln x plus 5 times y, and outside parentheses. Okay, so here, these both have the same base. Since I'm subtracting those, I'll write that as a single logarithm that has a quotient in it. So ln of x cubed over x plus 5 times y. And then that 4 I can write as an exponent. So this is going to be ln x cubed over x plus 5 times y. And that's all raised to the 4th power. Sorry, kind of ran out of room, but hopefully you can see that all. And then there's one other property we're going to look at, and that's called the change of base formula. And the change of base formula just says if I have a logarithm with some base b, I can rewrite that and change the base into something that I would like to use. And I have the m, which was the original argument, as the argument in the numerator, and then the b which is the original base, as the argument in the denominator. This is sometimes good because oftentimes, or maybe not oftentimes, but there may be times when we want to get things in terms of base 10 or base E. And if we're not originally in base E or base 10, this is how we can do it. Okay, so this one says evaluate log base 5 of 100 using the change of base formula. So I'm going to do this both as base 10 and as base E. Okay, so log base 5 of 100. So what the change of base formula says is I can rewrite this by picking any base, and the original argument becomes the argument up here, and then the original base becomes the argument here. Okay, so I could put any base in that box. So I could put 10 in there, okay, or I could put E in there. So that could also be ln of 100 or ln of 5. So either way will work. That ln of 100 over ln of 5, that's just log base E. All right, and then the last example, change log base 10 of 18 to a quotient of natural logarithms. So natural logarithms, that just means base E. So this will be ln of 18 over ln of 10. And again, ln just means log base E.